Hey, Honors Pre-Cal students. Just checking in during these crazy times. Hope everybody is being able to stay home and stay safe. I'm making this video to go over the three concepts that you've probably already noticed that there's a quiz on my MCPS or Canvas. If you've already noticed, I know some of you have already taken that, and there is a due date, not a deadline, a due date by the end of this week. And what'll happen is, I believe I'm going to make a second version for those of you that don't do well on this quiz, and I'm going to make a second version for a retake for next week. So hopefully this video is going to help you out. So the purpose of this video is to go over those three concepts. I know you've already had a chance, hopefully, to see the videos that have been posted on YouTube. But this is a very condensed version of practice for all three of those concepts. The first concept is graphing polar coordinates. So this would have been one of the first things that we would have done if we hadn't been out on this during this time. So during this distance learning, I'm going to show you how to do these things. I'm going to start off with this point right here. So polar coordinates are always the r and theta. So r is the radius of the circle. So you notice that a polar coordinate system is a circular system, not a rectangular. And theta happens to be the angle from the starting position. So starting position, as you learned back in Algebra 2, is the right-hand side. So this point right here is 6 poles. So this is the pole. This is the center. It's 6 circles away from the center. So that's its. So if you were to make this into a right triangle like such, then you would see that this radius is a distance of 6. It's 6 away from the center pole. And then the angle would be this angle all the way around. Now, it really doesn't matter which circle you use because it's going to be the same angle. So halfway around will be 180 degrees, and then you add this, looks like 60 more degrees, which makes 240 degrees. That's the reason why this is 6, 240 degrees. So it's not an X and a Y. That would be rectangular form. That's what you would use on a Cartesian graph. So this is polar form. So I'm going to go over a couple of these examples, and I have some examples I can do for you. Pi over 12, so it shows you right here, pi over 12 is 15 degrees. And then you go 3 away from the center. So this one right here, pi would be halfway around, but then it's -7 is the distance. So instead of going towards pi, you're going to go the opposite direction because it has the opposite radius. So instead of going 7 this way, it's 7 this way. So this one, 4 is 4th circle. So you can see this point right here at the 4th circle. And then it's -pi over 3. So keep in mind, -pi over 3 is 60 degrees going clockwise, going the opposite direction. All right, so let's look at some examples and move myself out of the way here. So it starts off nice and easy. So these are all points on a polar graph. So we're just talking about points here. We're not talking about equations or anything. So we're not graphing equations, which we'll cover later on. 3 comma pi over 3. So pi over 3 is 60 degrees. That's right here. And then 3 away from the center. 1, 2, 3. And that would be point A. B is -3 pi over 3. So pi over 3 is this direction, right? But instead of going 3, we're going -3, which means we're going the opposite direction, which is going to go 1, 2, 3 this way. So that's point B. And then C would be 5 negative pi over 6. Now, negative pi over 6 is -30 degrees, which is the same thing as 330 degrees. So pi over 6 is the second line. So that's 11 pi over 6. That's this line. And then 5, I got to start at center. 1, 2, 3, 4, 5. 5 is the blue. That happens to be C. And then D is -7. Okay, so we have a negative angle and a negative radius. So the first thing I'm going to do is go -7 pi over 6. So that's 6 pi over 6. So 7 pi over 6 would be 1/6 more. So that's this line right here represents -7 pi over 6. Because I went this way, 7 pi over 6. But it's then going -7. So I'm going to then go towards 11 pi over 6 because that's the opposite direction. And that would be 1, 2, 3, 4, 5, 6, 7. And there is point D. E is at 1 and 245 degrees. Now, 245 degrees is 45 degrees more than 180. So that would be right here towards 5 pi over 4. So remember, this is 245 degrees, because this is 1/4 pi more than pi, which is 4/4 pi. Then 1 would just be right there. That's point E. F is -4, -150. -150 is 30 degrees short of 180, which would be right here. So this would be -150 degrees. But then I'm going to go -4, which means I'm going to go the other way. 1, 2, 3, 4. Right there is point F. All right, hopefully that covers that. So converting rectangular form to polar coordinate systems. Now, rectangular form, as I've talked about in this video, is XY, which can be found as using the X coordinate and the Y coordinate of a Cartesian graph, where X represents left or right, Y represents up or down. It's what you've done all the time, all the way up to this point. Now, polar form is a different coordinate system, as we've just looked at. So it's a circular, because it's talking about the radius from the center pole and the angle in which it's going in. So remember, just like vectors, and that's the reason why we did vectors first, vectors have a magnitude and an angle in which they're going. So it's a direction in which they're going. In this case, the direction happens to be the angle from the starting position. So our theta is what we use. Now, these are rectangular. These are XYs, and I can tell because there's no degrees. It doesn't say radians right here. So it's pretty clear that this is a rectangular form. Now, one of the things that we have done in the past is we have been able to find the angle when given a point in standard form. So two things I need to know. I need to know the radius, and I need to know the angle. So I'll start off with the radius. Now, 3, 4 on a Cartesian graph, 1, 2, 3, 1, 2, 3, 4, creates this right triangle that you should have done back in Algebra 2. Now, how do I find the radius? How do I find the distance away from the center pole? Well, I use a Pythagorean theorem. This is 3 and this is 4. Then I should be able to do 3 squared plus 4 squared equals c squared, or square root of that equals c. So that equals the radius. So 3 squared is 9, and 4 squared is 16. And then add those two together, you get 25. Square root of 25 is 5. So now I know it's 5 something. So that would be 5 comma some sort of angle. Now, to find the angle of this right here, so the easiest, since we have the opposite and we have the adjacent side, the easiest way of doing that would be to use inverse tangent, because tangent is opposite over adjacent. Now, the reason I'm doing inverse is because tangent of theta equals 4 over 3. Now, how do I get theta by itself? By getting rid of the word tangent, I do the inverse tangent of both sides. So inverse tangent of tangent, so that basically cancels these out. And then you have inverse tangent over here of 4/3, which is really what I'm doing. So now I'm going to use my graphing calculator, and I'm going to put in inverse tangent of 4 divided by 3. I'm going to show you what that looks like, just like that. Make sure that you are in degrees, because it really doesn't matter in this case. So you can put radians if you want, but you have to put RAD. So that would be theta is about 53.1 degrees. And there you have it. Now you've got yourself a polar coordinate, which is in the exact same location as this rectangular coordinate. All right, so example number 2. So -2, 5. I'm going to do this exactly the same. Square root of -2 squared plus 5 squared. Now, keep in mind, if you're putting this in your graphing calculator, you need to put the -2 in parentheses, because a negative squared will always be a positive. -2 squared is 4, and 5 squared is 25. Add those together, you get square root of 29. So now I know the answer is square root of 29, comma, something. Now, inverse tangent of y over x. So inverse tangent of 5 divided by -2 gives me theta is -68.19. Now, keep in mind that -2,5 should be in the second quadrant. -2,5 is in the second quadrant. Now, remember, there's 2 answers. Whenever you do inverse tangent of a number, there's actually 2 answers, because tangent can be positive in both. So tangent is positive both in the 4th quadrant and all of them here. All students take calculus. I put the wrong one, sorry. Let me erase that. So tangent is actually positive in both the first and the third coordinate. Now, I forgot this was a negative. That's what made me think here. So that means that tangent is negative in both the second and the fourth quadrants. Now, I got an answer that happens to be in the fourth quadrant, but that's not the quadrant I want it to be in. So I'm going to have to add 180 to that. Adding 180 gets me the same answer in the second quadrant. So if I add 180 to that, then I'm going to get 111.8 degrees. And there you have it. You've got yourself a polar coordinate in this exact same place as this rectangular coordinate. And hopefully I'm going to have enough time to do one last concept, which is eliminating the parameter. I know this is parametric equations. This is the last topic, but this is also covered on the quiz because this is something that you should have learned during distance learning. These are the three concepts that end quarter 3. Now, I've written steps by step right here. Using the x parameter, you're going to solve for t. So if I'm going to solve for t, I would add 1 to both sides. That gives me x plus 1 equals 2t. And if I'm solving for t, I'm going to divide both sides by 2, so that x equals x plus 1 over 2. Now, I'm going to take this, and I'm going to substitute it right there and solve. So y equals x plus 1 over 2 plus 6. Now, what I'm going to do is I'm going to get rid of this division by multiplying everything by 2. So times 2, times 2, times 2. This times 2 divided by 2 cancels each other out. So I've got 2y equals 2x plus 2 minus 12. Because 2, I'm sorry, plus 12. I thought that was a negative. My mistake. So that's plus 12. 6 times 2 is 12. Now, this can be combined. 2y equals 2x plus 14. Now, I did say I'm going to simplify by putting things in the standard form. That's kind of optional. But if I'm going to put it in standard form, I'm going to move the 2x to the other side. So 2y minus 2x equals 14. Really doesn't matter. You can leave it just like this. Either one of these are the exact same thing. If you don't really have to convert things in the end, I just like to because if it's a circle, then I would kind of want to be able to change it to standard form because I can, graph it. So it might make it easier to put it in the standard form. All right, so let me see if I can get rid of this and just start over for the next one. So this time I have square root, so I'm going to solve for t. The first thing I'm going to do is square both sides. So that gives me x squared equals t plus 1, and then subtract 1 from both sides so that t equals x squared minus 1. Now I'm going to take this, I'm going to plug it in right there. So that y equals x squared minus 1 plus 7. Well, there isn't anything to do inside the parentheses, so really the parentheses are not necessary. You can just combine like terms. Y equals x squared plus 6. All right, now, I could, once again, rearrange this to like negative x squared plus y equals 6, but that's going to be the exact same thing. This is probably what you would see as an answer for this question because, since it's squared. All right, that is it. Thank you again for watching this, and since I have 2 minutes left, I just want to once again go over the expectations. Hopefully you're watching the videos that I'm creating, especially when we get to marking period 4. Things are going to be pushed out through YouTube. I'm also going to post all those videos on MyMCPS and Google Classroom, but always check MyMCPS because that's where the modules are going to be posted, and there will be checkpoints and quizzes, just things to make sure that you're keeping up and doing all the lessons and that you understand the lessons. If you ever have any questions, please feel free to email me or write questions on the videos or message me however you want. You can also turn in makeup work by sending pictures of classwork that you have done. Thank you for everything and watching this video. And please give it a like. Actually, I'm not going to post this on YouTube, but please let me know if this helped. And like I said before, if you don't do well on the quiz, then at the end of this week when the answers are posted, I'm going to make up another version of it, which you don't need to take if you did well. Only take it if you wish to retake your assignment. All right, thanks again for watching, and stay healthy.